So let's continue with sulfonation. So sulfonation is yet again a fairly elementary concept, because it's also quite easy, though there are only a few slight differences that you need to take note of. So before we dive into doing the mechanism of sulfonation, another important thing to know is sulfonation, amongst all the reactions benzene can participate in, has something unique. So it's the only reaction that's dependent on the concentration of the catalyst that you're going to use, right? And so what do I mean? So if you started with benzene, like we said in the halogenation video, we said benzene is fairly stable and so does not want to react. So in order for it to react, in this particular case, we need to use sulfuric acid, right? But then an important thing to take note of is that this reaction is very much dependent on the concentration of that sulfuric acid. So what do I mean? What do I mean? I mean this. So what I mean is, if you have concentrated sulfuric acid, this reaction will tend to go forward, and then you form this. You form this. You form this. This is a 3 here. You form this. Yeah, okay. You form something like this. And then if it's under dilute, right? So if you have dilute sulfuric acid, this reaction tends to revert back into water, into benzene. So that's an important concept to take note of. So the concentration matters. So how is this reaction typically done? So whenever you want to run a sulfonation reaction, pretty much the same as all the other reactions, you start off with benzene. So you get your benzene there. There's benzene. Start off with benzene, and then you need to react it. So there are two ways you could run this reaction. So the first way is you could use 2 molecules of sulfuric acid. And then the other way is you could use sulfur trioxide and sulfuric acid. At the end of the day, both processes are the same. So I'll use 2 molecules of sulfuric acid, and then you see where the sulfur trioxide will come in. And then what do you expect to form? So at the end of the day, you form something that will look like this. You have your SO3H. You produce a little bit of water, and then your catalyst will come back. Right? So for that alone, you have marks already, if this was an exam. So how do we do this reaction? In steps. Step 1, you generate what? You generate your electrophile. So the electrophile we're trying to generate here is sulfur trioxide gas. Sulfur trioxide gas is a very potent what? Electrophile. The potent electrophile. So we generate this, our sulfur trioxide gas. And so what do? We start off with this. So if you mess up the structure of sulfuric acid, you definitely mess up everything. So you need to be able to remember how to draw the Lewis structure of sulfuric acid. So it looks like that. Right? And then you react it with another sulfuric acid. Like that. So what do you expect to happen in the first reaction? So in the first reaction, one of these would deprotonate. So it could be either one of these. So I'll deprotonate this one here. And when it deprotonates, it will lose the proton. Because what's the definition? It will lose the proton. Because what's the definition of an acid? An acid is a substance that when you put it in aqueous media, it loses hydrogen. Or it produces hydrogen as the only positively charged water ions. So that's what this will do. But then now what will happen is that the proton will be picked up. It will be deprotonated in such a way. So if you remember, we said our arrow should always go from electron rich to electron poor, like that. And so what will you form after that happens? So you have this part, exactly the way it is. And then it's picked up a proton, so it looks like this now. Plus, we'll also have this part here. Right? Are we okay up to that point? What's the major difference? The major difference is here, right? So this has been deprotonated. So what's the new charge here? The new charge is negative. What did we say in the previous video? We said that, for example, if oxygen should normally bond to two things, if it makes more bonds than it normally does, like suppose it bonded to three things, it would be positive. If it makes less bond than it normally does, it will bear a negative formal charge. So this is what is happening here. So oxygen should normally bond to two things. Now it's bonding to one thing, therefore it must have a negative formal charge. What about here? It should normally bond to two things, now it's bonded to three things, therefore it has a positive formal charge. Now the question is it happy having a positive formal charge? No, it is not. And so the best way for it to, be happy is if this happens. Right? And so when that happens, at the end of the day, you will have something that will look like this. And then we'll also have something like that. Okay? So water will participate as a base, even though water is amphoteric, right? It could be a base, it could be an acid, but in this particular case, it could participate as a base. And then this could participate as, this could be our conjugate base, right? And then this could be our electrophile, although some books would use it like that. But then I want to show you where this is coming from, the sulfur trioxide, right? And so one thing that could happen is this can also be deprotonated by the water or either one of the two bases. So I'll deprotonate it using this. So one thing will happen, one thing that can happen is this. So because we don't have enough space, the line will be a bit bent like that. But then which direction should the arrow go? From electron rich to electron poor, such that at the end of the day, you have something that looks like this. So you have that there, or let me do it in advance. So one thing you'll be able to see is that this lone pair will remain there, right? And then it could scooch over there. And then you have a double bond. So at the end of the day, the structure will look like this. Right? And then you have your hydronium ion. Like this. And then you have your conjugate base. Right? This is what you have. This here is your electrophile. Right? This here will behave as our base, kind of, and although it's an acid right now, right? But then it's conjugate acid, and then you have a conjugate base there. Okay? So this is your electrophile. So I'll write our electrophile there so that we can keep track. It's positive. So what's our second step after we generate our electrophile? So I know this might seem complicated, but it's not as hard as it looks. Just practice this a few times and you'll be able to get it. So what do we do after we generate our electrophile? We show attack. So we could say aromatic attack. We show aromatic attack. So what are we doing? We start with our benzene. And then what are we doing? We illustrate an attack. Right? Using our electrophile. And so what do you do? So this could attack there, could attack that bond there. And then when it does that, one thing you'll be able to see is you'll form something that will look like this. This group will come sit here. So why did I break this bond? Why did I do that? So I did that because sulfur typically should make 6 bonds, right? So you needed to make 6 bonds. If I kept that bond, it would have made 7. Yeah, so it needs to make 6 bonds. But then let's take note that the hydrogen is still there, right? Because everything is here, there is a deficiency of electrons there. And then we need to do the next step, which is resonance. So in resonance, what do? We start with our structure. So for simplicity, I'll just say SO3, right? Like that. So first thing, what do you expect? This will scooch over, come there. There it is, there it is. This will skip a corner, it's there, right? Second thing, this moves there, comes there, comes there. Then we'll have our positive charge there. It skips this corner, it comes there. And then it moved all the way from there to there. This is our uranium ion. This is our uranium ion, right? Next step, restoration. So how do you do restoration? So when doing restoration, you start with that one there. Right? The hydrogen there. And then you're reacting it. You're reacting it with what? You're reacting it with the conjugate base. So how did our conjugate base look like? If you remember, the conjugate base looked like this. Right? So what happens? This will happen. But then our arrow should go from electron rich to electron poor. At the end of the day, what will you form? So the first thing that you'll be able to form is you form this. So the hydrogen will go there, and then we'll form sulfuric acid again. We'll form our sulfuric acid. And then what will happen? This leaves, so this leaves the pair of electrons and then pushes it back there. And so we'll also form sulfuric acid plus, and then our next structure will look like this. Right? Take note that this part, this entire time is negative for reasons that I explained before. Right? So this part could react with our hydronium. We produced hydronium at some point, right? It looked like this. Could react with hydronium. And then what will happen is this deprotonation will happen. And then what do you expect at the end of the day? You expect our final products, which will look like this. So you have sulfuric acid, right? What else do you have? Because we're deprotonating, we'll have water left. And then after that, we'll also have this. S or 3, because 1, 2, 3. And then the hydrogen. That's exactly the same things were expected to have had. So I know it might seem a bit difficult, but all you need to do is practice and everything will be okay. So that's the end of the video.